An exoplanet is a planet located outside the solar system. The first confirmation of an exoplanet orbiting a main sequence star was made in 1995, when a giant planet was found in a 4-day orbit around the nearby star 51 Pegasi. Some exoplanets have been imaged directly by telescopes, but the vast majority have been detected through indirect methods such as the transit method and the radial-velocity method. As of November 20, 2014, astronomers have identified 1850 such planets. This is a list of the most notable discoveries. 1988 to 1992, Gamma Cepheus Ab. The radial velocity variations of the star Gamma Cepheus were announced in 1989, consistent with a planet in a 2.5-year orbit. However, misclassification of the star as a giant combined with an underestimation of the orbit of the Gamma Cepheus binary, which implied if the planet's orbit would be unstable, led some astronomers to suspect the variations were merely due to stellar rotation. The existence of the planet was finally confirmed in 2002. HD 114762b, this object has a minimum mass 11 times the mass of Jupiter and has an 89-day orbit. At the time of his discovery it was regarded as a probable brown dwarf, although subsequently it has been included in catalogues of extrasolar planets. PSRB 1257+12. The first confirmed discovery of extrasolar planets was made in 1992 when a system of terrestrial mass planets was announced to be present around the millisecond pulsar PSRB 1257+12. 1995 Euro 1998, 51 Pegasi B. In 1995 this became the first exoplanet orbiting a main sequence star to have its existence confirmed. It is a hot Jupiter with a 4.2-day orbit. 47 Ursae Majoris B. In 1996 this Jupiter-like planet was the first long-period planet discovered, orbiting at 2.11 AU from the star with the eccentricity of 0.049. There is a second companion that orbits at 3.39 AU with the eccentricity of 0.220 at plus or minus 0.028 and a period of 2190 at plus or minus 460 days. Gliese 876b. In 1998, the first planet was found that orbits around a red dwarf star. It is closer to its star than Mercury is to the Sun. More planets have subsequently been discovered even closer to the star. 1999, Upsilon Andromedae, the first multiple planetary system to be discovered around a main sequence star. It contains 3 planets, all of which are Jupiter-like. Planets B, C, D were announced in 1996, 1999, and 1999 respectively. Their masses are 0.687, 1.97 and 3.93 megajoules. They orbit at 0.0595, 0.830, and 2.54 AU respectively. In 2007 their inclinations were determined as non-coplanar. HD 209458b, after being originally discovered with the radial-velocity method, this became the first exoplanet to be seen transiting its parent star. The transit detection conclusively confirmed the existence of the planet suspected to be responsible for the radial velocity measurements. 2001, HD 209458b, astronomers using the Hubble Space Telescope announced that they had detected the atmosphere of HD 209458b. They found the spectroscopic signature of sodium in the atmosphere, but at a smaller intensity than expected, suggesting that high clouds obscure the lower atmospheric layers. In 2008 the albedo of its cloud layer was measured, and its structure modeled as stratospheric. Iota Draconis b, the first planet discovered around the giant star Iota Draconis, an orange giant. This provides evidence for the survival and behavior of planetary systems around giant stars. Giant stars have pulsations that can mimic the presence of planets. The planet is very massive and has a very eccentric orbit. It orbits on average 27.5% further from its star than Earth does from the Sun. In 2008 the system's origin would be traced to the Hyades cluster, alongside Epsilon Tauri. 2003, PSRB 1620-26b, On July 10, using information obtained from the Hubble Space Telescope, a team of scientists led by Stein Segura de Griesen confirmed the oldest extrasolar planet yet. The planet is located in the globular star cluster M4, about 5,600 light-years from Earth in the constellation Scorpius. This is one of only 3 planets known to orbit around a stellar binary. One of the stars in the binary is a pulsar and the other is a white dwarf. The planet has a mass twice that of Jupiter, and is estimated to be 12.7 billion years old. 2004 Microns Array C, in August, a planet orbiting Mu Array with a mass of approximately 14 times that of the Earth was discovered with the European Southern Observatory's HARP spectrograph. Depending on its composition, it is the first published hot Neptune, or super-Earth. 2M1207b, the first planet found around a brown dwarf. The planet is also the first to be directly imaged. According to an early estimate, it has a mass 5 times that of Jupiter. Other estimates give slightly lower masses. It was originally estimated to orbit at 55 AU from the brown dwarf. The brown dwarf is only 25 times as massive as Jupiter. The temperature of the gas giant planet is very high, mostly due to gravitational contraction. In late 2005, the parameters were revised to orbital radius 41 AU and mass of 3.3 Jupiters, because it was found that the system is closer to Earth than was originally believed. In 2006, a DAS disk was found around 2M1207, providing evidence for active planet formation. 2005, TRES-1 and HD 209458b, on March 22, 2 groups announced the first direct detection of light emitted by exoplanets, achieved with the Spitzer Space Telescope. These studies permitted the direct study of the temperature and structure of the planetary atmospheres. Gliese 876d, on June 13, a third planet orbiting the red dwarf star Gliese 876 was announced. With a mass estimated at 7.5 times that of Earth, it may be rocky in composition. The planet orbits at 0.021 AU with a period of 1.94 days. HD 149026b, this planet was announced on July 1. Its unusually high density indicated that it was a giant planet with a large core, the largest one yet known. The mass of the core was estimated at 70 Earth masses, accounting for at least 2/3 of the planet's total mass. 2006, Ogle 2005 BLG 390 pounds, this planet, announced on January 25, was detected using the gravitational microlensing method. It orbits a red dwarf star around 21,500 light-years from Earth, towards the center of the Milky Way galaxy. As of April 2010, it remains the most distant known exoplanet. Its mass is estimated to be 5.5 times that of Earth. Prior to this discovery, the few known exoplanets with comparably low masses had only been discovered in orbits very close to their parent stars, but this planet is estimated to have a relatively wide separation of 2.6 AU from its parent star. Due to that wide separation and due to the inherent dimness of the star, the planet is probably the coldest exoplanet known. HD 69830, has a planetary system with 3 Neptune-mass planets. It is the first triple planetary system without any Jupiter-like planets discovered around a Sun-like star. All 3 planets were announced on May 18 by Lovis. All 3 orbit within 1 AU. The planets B, C and D have masses of 10, 12 and 18 times that of Earth, respectively. The outermost planet, D, appears to be in the habitable zone, shepherding a thick asteroid belt. 2007, HD 209458b and HD 189733b, these became the first extrasolar planets to have their atmospheric spectra directly observed. The announcement was made on February 21, by 2 groups of researchers who had worked independently. One group, led by Jeremy Richardson of NASA's Goddard Space Flight Center, observed the atmosphere of HD 209458b over a wavelength range from 7.5 to 13.2 micrometers. The results were surprising in several ways. the 10-micrometer spectral peak of water vapor was absent. An unpredicted peak was observed at 9.65 micrometers, which the investigators attributed to clouds of silicate dust. Another peak, at 7.78 micrometers, remained unexplained. The other group, led by Carl Grillmeyer of NASA's Spitzer Science Center, observed HD 189733b. They also failed to detect the spectroscopic signature of water vapor. Later in the year, yet another group of researchers using a somewhat different technique succeeded in detecting water vapor in the planet's atmosphere, the first time such a detection had been made. Gliese 581c, a team of astronomers led by Stefan Udry used the HARPS instrument on the European Southern Observatory's 3.6-meter telescope to discover this exoplanet by means of the radial-velocity method. The team calculated that the planet could support liquid water and possibly life. However, subsequent habitability studies indicate that the planet likely suffers from a runaway greenhouse effect similar to Venus, rendering the presence of liquid water impossible. These studies suggest that the third planet in the system, Gliese 581d, is more likely to be habitable. Seth Shostak, a senior astronomer with the SETI Institute, stated that 2 unsuccessful searches had already been made for radio signals from extraterrestrial intelligence in the Gliese 581 system. Gliese 436b, this planet was one of the first Neptune-mass planets discovered, in August 2004. In May 2007, a transit was found, revealed as the smallest and least massive transiting planet yet at 22 times that of Earth. Its density is consistent with a large core of an exotic form of solid water called hot ice, which would exist, despite the planet's high temperatures, because the planet's gravity causes water to be extremely dense. TRES-4, the largest diameter and lowest density exoplanet to date, TRES-4 is 1.7 times Jupiter's diameter but only 0.84 times its mass, giving it a density of just 0.2 grams per cubic centimeter, about the same as balsa wood. It orbits its primary closely and is therefore quite hot, but stellar heating alone does not appear to explain its large size. 2008, Ogle 2006 BLG 109 pounds and Ogle 2006 BLG 109 LC. On February 14, the discovery of a planetary system was announced that is the most similar one known to the Jupiter-Saturn pair within the Solar System in terms of mass ratio and orbital parameters. The presence of planets with such parameters has implications for possible life in a solar system, as Jupiter and Saturn have a stabilizing effect to the habitable zone by sweeping away large asteroids from the habitable zone. HD 189733b, on March 20, follow-up studies to the first spectral analyses of an extrasolar planet were published in the scientific journal Nature, announcing evidence of an organic molecule found on an extrasolar planet for the first time. The analysis showed not only water vapor, but also methane existing in the atmosphere of the giant gas planet. Although conditions on there are too harsh to harbor life, it still is the first time a key molecule for organic life was found on an extrasolar planet. HD 40307, on June 16, Michel Mayor announced a planetary system with 3 super-Earths orbiting this K-type star. The planets have masses ranging from 4 to 9 Earth masses and periods ranging from 4 to 20 days. It was suggested this might be the first multi-planet system without any known gas giants. However, a subsequent study of the system's orbital stability found that tidal interactions have had little effect on evolution of the planet's orbits. That, in turn, suggests that the planets experience relatively low tidal dissipation and hence are of primarily gaseous composition. All 3 were discovered by the HARPS spectrograph in La Silla, Chile. 1 are XSJ 160929.1 or 210524. In September, an object was imaged in the infrared at a separation of 330 AU from this star. Later, in June 2010, the object was confirmed to be a companion planet to the star rather than a background object aligned by chance. Fomalhaut B, on November 13, NASA and the Lawrence Livermore National Laboratory announced the discovery of an extrasolar planet orbiting just inside the debris ring of the A-class star Fomalhaut. This was the first extrasolar planet to be directly imaged by an optical telescope. Its mass is estimated to be 3 times that of Jupiter. Based on the planet's unexpected brightness at visible wavelengths, the discovery team suspects it is surrounded by its own large disk or ring that may be a satellite system in the process of formation. HR 8799, also on November 13, the discovery of 3 planets orbiting HR 8799 was announced. This was the first direct image of multiple planets. Christian Maroy of the National Research Council of Canada's Hertzberg Institute of Astrophysics and his team used the Keck and Gemini telescopes in Hawaii. The Gemini images allowed the international team to make the initial discovery of 2 of the planets with data obtained on October 17, 2007. Then, in July through September 2008, the team confirmed this discovery and found a 3rd planet orbiting even closer to the star with images obtained at the Keck 2 telescope. A review of older data taken in 2004 with the Keck 2 telescope revealed that the outer 2 planets were visible on these images. Their masses and separations are approximately 7 megajoules at 24 AU, 7 megajoules at 38 AU, and 5 megajoules at 68 AU. 2009, Ursae 7b, on February 3, the European Space Agency announced the discovery of a planet orbiting the star Ursae 7. Although the planet orbits its star at a distance less than 0.02 AU, its diameter is estimated to be around 1.7 times that of Earth, making it the smallest super-Earth yet measured. Due to its extreme closeness to its parent star, it is believed to have a molten surface at a temperature of 1000 (1500 AA degrees Celsius. It was discovered by the French Corot satellite Gliese 581e. On April 21, the European Southern Observatory announced the discovery of a 4th planet orbiting the star Gliese 581. The planet orbits its parent star at a distance of less than 0.03 AU and has a minimum mass estimated at 1.9 times that of Earth. As of January 2010, this is the lightest known extrasolar planet to orbit a main sequence star. 30 planets. On October 19, it was announced that 30 new planets were discovered, all were detected by radial-velocity method. It is the most planets ever announced in a single day during the exoplanet era. October 2009 now holds the most planets discovered in a month, breaking the record set in June 2002 and August 2009, during which 17 planets were discovered. 61 Virginis and HD 1461, on December 14, 3 planets were discovered. Also a super-Earth planet and 2 unconfirmed planets around HD 1461 were discovered. These discoveries indicated that low-mass planets that orbit around nearby stars are very common. 61 Virginis is the first star like the Sun to host the super-Earth planets. GJ 1214b, on December 16, a super-Earth planet was discovered by transit. The determination of density from mass and radius suggests that this planet may be an ocean planet composed of 75% water and 25% rock. Some of the water on this planet should be in the exotic form of ice 7. This is the first planet discovered by MARF project, which is used to look for transits of super-Earth planets crossing the face of M-type stars. 2010, 47 Ursae Majoris d, on March 6. A gas giant like Jupiter with the longest known orbital period for any exoplanet was detected via radial velocity. It orbits its parent star at a distance similar to Saturn in our solar system with its orbital period lasting about 38 Earth years. Cora 9b, on March 17, the first known temperate transiting planet was announced. Discovered by the Corot satellite, it has an orbital period of 95 days and a periastron distance of 0.36 AU, by far the largest of any exoplanet whose transit has been observed. The temperature of the planet is estimated at between 250 K and 430 K, Beta Pictoris b, on June 10. For the first time astronomers have been able to directly follow the motion of an exoplanet as it moves to the other side of its host star. The planet has the smallest orbit so far of all directly imaged exoplanets, lying as close to its host star as Saturn is to the Sun, HD 209,458b. On June 23, astronomers announced they have measured a superstorm for the first time in the atmosphere of HD 209,458b. The very high-precision observations done by Ursae unregistered trademark S Very Large Telescope and its powerful KIRS spectrograph of carbon monoxide gas show that it is streaming at enormous speed from the extremely hot day side to the cooler night side of the planet. The observations also allow another exciting first measuring the orbital speed of the exoplanet itself, providing a direct determination of its mass. HD 10180, on August 24, astronomers using Ursae unregistered trademark S-HARPS instrument announced the discovery of a planetary system with up to 7 planets orbiting a Sun-like star with 5 confirmed Neptune mass planets and evidence of 2 other planets, one of which could have the lowest mass of any planet found to date orbiting a main sequence star, and the other of which may be a long-period Saturnian planet. Additionally, there is evidence that the distances of the planets from their star follow a regular pattern, as seen in our solar system. 2011, Kepler 11, on February 3, astronomers using NASA's Kepler mission announced the discovery of 6 transiting planets orbiting the star Kepler 11. Masses were confirmed using a new method called transit timing variations. The architecture of the system is unique with 6 low-mass, low-density planets all packed in tight orbits around their host star. The 5 inner planets all orbit inside that of Mercury in our solar system. It is believed that these planets formed out past the snow line and migrated into their current position. 55 Cancri, on April 27, 2011, the super-Earth 55 Cancri was found to transit its host star using the MOST satellite. This planet has the shortest known orbital period of any extrasolar planet at 0.73 days. It is also the first time a super-Earth has been detected transiting a naked-eye star. The high density calculated suggests that the planet has a rock-iron composition supplemented by a significant mass of water, gas, or other light elements. 2012. Alpha Centauri Bb, on October 16, 2012. The discovery was announced of an Earth-mass planet in orbit around Alpha Centauri b. The discovery was published online on 17 October, in the scientific journal Nature, and the lead author of the paper was Xavier Dumusc, a graduate student at the Centro de Astrofísica da Universidade do Porto. The discovery of a planet in the closest star system to Earth received widespread media attention, and was seen as an important landmark in exoplanet research. 2013, Penthouse 2b, on January 3, 2013, the discovery of a Jupiter-size extrasolar planet that could potentially be habitable was announced. The exoplanet was discovered by amateur astronomers from the Planet Hunters project of amateur astronomers using data from the Kepler mission Space Observatory and confirmed, with 99.9% confidence, by observations at the W.M. Keck Observatory in Hawaii. Penthouse 2b is the second confirmed planet discovered by planethunters.org. Kepler 69c, on January 7, 2013, the discovery of an unconfirmed candidate exoplanet was announced by astronomers affiliated with the Kepler mission Space Observatory. The candidate object, a super-Earth, has a radius 1.54 times that of Earth. Kepler 69c orbits a Sun-like star, named Kepler 69, within the habitable zone, a zone where liquid water could exist on the surface of the planet. Scientists claim the exoplanet, if confirmed, could be a prime candidate to host alien life. On April 18, 2013, NASA announced the discovery of 3 new Earth-like exoplanets, Kepler 62e, Kepler 62f, and Kepler 69c in the habitable zones of their respective host stars, Kepler 62 and Kepler 69. The new exoplanets, which are considered prime candidates for possessing liquid water and thus potentially life, were identified using the Kepler Space Observatory. 2014, on February 26, 2014, NASA announced the discovery of 750 newly verified exoplanets around 305 stars by the Kepler Space Telescope. The exoplanets were found using a statistical technique called verification by multiplicity. 95% of the discovered exoplanets were smaller than Neptune, and 4, including Kepler 296f, were less than 2½ the size of Earth and were in habitable zones where surface temperatures are suitable for liquid water. In July 2014, NASA announced the determination of the most precise measurement so far attained for the size of an exoplanet. The discovery of an exoplanet that has the longest known year of any transiting planet found so far. And, finding very dry atmospheres on 3 exoplanets orbiting Sun-like stars. References. External links.